Picture falling asleep to the Pacific doing its usual slow, steady gnawing in California, then waking up to a coast that's jumped 6 feet overnight. From the Bay Area down toward LA, beaches hang above the surf, docks sit crooked in midair, tide pools are suddenly bone dry, and sea life is stranded like the ocean got yanked away. Every GPS station and satellite screams the same thing. The land rose fast, and the scary part? There was no earthquake, no sound, no warning. That's the part that twists your stomach. California is not a quiet place geologically, but it is a predictable kind of restless. The coastline sits on a boundary where the Pacific Plate and the North American Plate are forever rubbing shoulders. Over millions of years, that friction has written the state's whole personality. Faults, cliffs, basins, mountains that look like they're still deciding where they want to be. And yet, most days the motion is so slow that it feels like a myth. And the record we live by, vertical land movement along the coast is measured in millimeters per year, 0 to 4 millimeters annually in many stretches. Even at the more active spots, you're talking about changes thinner than a fingernail, logged quietly by instruments that are absurdly sensitive. JPL scientists can see the ground heave or sag by fractions of a millimeter. In Santa Barbara, long-term sensors have clocked uplift on the order of 2 or 3 millimeters a year. In Long Beach or other heavily engineered areas, humans can push the land up or down a few centimeters over time through oil extraction, groundwater pumping, or recharge projects. But even then, it's gradual, trackable, and localized. The general story of the modern California coast is actually subsidence, land sinking as aquifers drain and sediments compact under cities. So 6 feet overnight doesn't live in any normal sentence a geologist would ever say with a straight face. Which is why, when the first batch of GPS stations started reporting jumps that big, the reaction wasn't curiosity, it was alarm and then disbelief, then a hard scramble for a simpler explanation. The accepted physics say a shift like that, at that scale and speed, needs something huge. An earthquake ripping a fault, a volcanic intrusion inflating the crust, a catastrophic collapse. Something. But the seismic networks were flat. No tremors, no clustered microquakes, not even the background chatter you'd expect if the crust was suddenly rearranging itself. The land appeared to rise in silence, and that leaves you with a choice no one wants. Either nature did something we don't have a name for, or the most advanced monitoring system on Earth simultaneously hallucinated the exact same impossible thing. And so the audit begins, and if you've ever watched scientists under pressure, it's a mix of cold method and rising dread. The first move is always to go back to the rawest layer. At JPL and partner labs, teams pulled original RINEX files from every station that flagged the step. Those files are timestamps, satellite signals, and math before any smoothing or interpretation. They checked maintenance records, antenna swaps, nearby construction, soil stability under the monuments, everything that could nudge a receiver into line. They compared time references, hunting for a silent shift in the global coordinate system, because a tiny misalignment in the International Terrestrial Reference Frame can, in theory, produce an artificial vertical step. That possibility is rare, but it's in the realm of annoying but solvable. The problem is that the anomalies didn't behave like a frame slip. They were consistent across independent networks, including stations tied to different reference solutions. You can't explain that away with a single bookkeeping error. On to the next suspect, the atmosphere. Tropospheric water vapor and ionospheric disturbances can bend GPS signals just enough to introduce false elevation changes. Solar storms, sharp weather fronts, calibration gaps, those can all add noise too. So engineers poured through correction tables, checked recent storms, looked at solar activity. Even a bad atmospheric model might smear a signal by centimeters. But 6 feet isn't an atmospheric artifact, it's an entirely different universe. If that number is fake, the lie has to be structural. Then INSAR radar comes into the room. Satellite interferometry that measures ground deformation by comparing phase differences between repeated passes. Yes, INSAR has its own demons, especially phase unwrapping errors where software miscounts wave cycles and turns gentle terrain into apparent cliffs. So they ran coherent tests over hundreds of frames, scanning for low-quality zones or edge effects. If the uplift was a processing ghost, it would show up patchy, pixelated, or tied to areas where coherence falls apart. Instead, the step traced across city blocks, farmland, rocky headlands, and open coast in a broad, clean swath. No seams, no islands of error, the satellites were agreeing with the GPS, and that's when the room gets quiet in a way that isn't comforting. Redundancy is the standard that keeps geology honest. A real signal has to appear in multiple independent datasets, and this one did. GPS says the ground rose, NSAR says the ground rose, tide gauges say sea level suddenly dropped relative to land, a mirror image of uplift. Leveling surveys in key areas confirm a new baseline. For all of those systems to fail in exactly the same direction at the same time over the same hundreds of miles is beyond unlikely. It's closer to unimaginable. Each usual culprit, multi-path reflections, antenna glitches, software bias, frame offsets, gets tested and crossed off. The investigation that was supposed to calm the panic actually ends up sharpening it. And that's where history starts whispering in the background. California has seen rapid ground movement without earthquakes before, but always in narrow, brutal pockets. The Portuguese Bend landslide, south of LA, is the classic example. In 1956, the bluff there started to go. People woke up to cracks in roads and lawns. And over months, the ground shifted more than 20 feet and took dozens of homes with it. The slide never fully stopped. It still creeps today, sometimes inching forward, sometimes surging after heavy rain. More recently, the winters of 2022 and 2023 soaked the state with storm systems that dumped far above normal rainfall. Old slide plains reactivated, groundwater tables rose, and parts of Portuguese Bend moved at rates that hit 30 centimeters a week, wild by any modern standard. Geotechnical teams found deeper layers sliding, not just surfacing. This kind of motion creates something called the uplift. As the mass pushes seaward, its leading edge collides with harder rock and buckles upward under compression. It's a real physical phenomenon. It can lift ground without an earthquake. But it's local, it's messy, and it's tied to the geometry of a specific slope. It doesn't quietly raise 400 miles of coastline in a single night. So, again, the question returns. Heavier each time. If it's not the instruments and it's not a known process, then what is it? While scientists argue in labs and over video calls, the coast itself is dealing with consequences nobody wrote a handbook for. Ports like Los Angeles and Long Beach are engineered to the millimeter. Their entire existence depends on sea level relative to land. When the shoreline jumps, the ocean doesn't politely follow. Container ships sit stranded on exposed mudflats. Cranes can't reach water that has fallen away from them. Fishing boats tilt on their keels above ranges they once floated. Billions in daily trade freeze in place. Supply chain managers start counting how long fresh produce stays fresh when it can't unload. Insurance models that know how to price earthquakes or tsunamis trip over a disaster that doesn't fit a category yet. This kind of uncertainty is its own form of panic. The ecological hit lands even faster. Tide pools bake in sun that never touched them from long before. Starfish and anemones dry out where they once rode the hush of each wave. Seals and seabirds get marooned in hauling out zones that are suddenly too high and too far from the surf. Marine biologists rush in with volunteers and makeshift rescue lines, and even in the best case, you're fighting the scale of an entire coastline changing shape while you're still trying to understand how. And then comes the public feud, because big mysteries do that. A private satellite analytics firm drops its own numbers within hours, claiming even sharper confirmation of a 6-foot step. The USGS pushes back, warning that satellite-only solutions can be distorted by atmospheric bias or processing assumptions. The firm fires back, accusing government networks of clinging to outdated ground stations. Leaked emails show researchers on both sides tearing apart each other's calibration protocols. Social media turns into a spectacle. Reporters kick off Freedom of Information Act requests, hunting raw files, internal memos, any hint of classified experiment, a hidden drilling project, an underground detonation. Official denials arrive, but rumors don't care about denials when the ground itself seems to be breaking etiquette. Here's where things stand after the first day that felt like a year. Multiple independent systems confirm vertical land motion up 6 feet along more than 400 miles of coast. Field audits and raw file reviews have ruled out the usual sensor failures. The uplift pattern doesn't match any known earthquake signature, volcanic event, or documented landslide precedent at anything close to this scope. The coast is still rising in some measurements, which is either a staggering reality or a sign of a phenomenon we're still misreading. And the professionals who live by solid answers are stuck saying a sentence that rarely leaves their mouths: "We don't know." So, what are your thoughts? Let us know in the comments down below, and don't forget to like and subscribe.